Data processing applications are typical programs that deal with large data and use data processing frameworks like OpenCV, TensorFlow, or PyTorch. Now, these frameworks can be vulnerable. For example, in 2022, there were more than 200,000 repositories on GitHub using TensorFlow, and in the same time, there were 164 reported CVEs for TensorFlow, meaning that there are more than 32 million potential vulnerabilities surrounding such data processing applications, making it critical to protect them. One solution to reduce the risk from vulnerable APIs is software isolation. What software isolation does is that it partitions the program into various isolated processes, making the vulnerable part of the program isolated. Unfortunately, most software isolation techniques are not practical, where some expose sensitive data and others have high overhead after partitioning. So when designing software isolation, we need to consider both the security as well as the performance to make it practical. So to design FreePart, we observe the data processing pipeline, and we observe 4 general phases where we find it natural to partition. In doing so, we end up with 4 partitions: data loading APIs, data processing APIs, data visualizing, and data storing. We evaluate FreePart on 23 real-world applications using the popular data processing frameworks, having 18 unique CVEs. We find that FreePart is effective against all attacks with only 3.68% overhead.